Okay, in this problem, we're going to be wrapping up looking at hypothesis testing, and we're going to be using practice problem 7. So let's go through and take a look at how we would use the StatCrunch software when we were looking at this particular problem. So here we have what we had laid out before in terms of our hypothesis and what we were solving for. I've set the alpha level for this as 0.05, so that's my setting it at that particular value. Again, normally in the problem, they should specify what alpha they're asking you to solve for, or they give you a confidence interval, which you can calculate your alpha. Now, we need to identify the relevant test statistic here. So notice we're asking for a mean pulse rate. So we're in the middle of this particular table because we're solving for a mean. And the next we need to be asking ourselves is which one of these two options are we using? So is our standard deviation for our population known or not known? In this case, it is not known. So we need to next ask ourselves, do we know if the distribution, if the population is normally distributed? And the answer for that is no, we do not. Do we know we have an n greater than 30? The answer for that is yes. If we look at the data set, we've got setup of 40 samples. So we're going to be using our t distribution. Okay, so that's the sampling distribution we're working with, is the t distribution. So here we have our alpha. Now we've identified our relevant test statistic as t. And now again, we're going to be looking at solving this problem. We're going to use the p-value method, and we're going to then come back and do the critical value method. So using the p-value method, we're going to find our test statistic, and doing this again, use our StatCrunch. So again, in StatCrunch, you're going to open stat, but now you're going to open tstat, since that's what we're solving for here. And then you're going to open one sample, and again, you have the option of opening it with summary or with data. In this particular option, we're going to be using with summary. But keep in mind, you can also go through to open it up with the data. So pause the video here while you get your StatCrunch open. And then when you're ready to proceed to the next part, turn the video back on and we'll work through this together. All right, you should get something that looks like this for your dialog box. Now, let's go through and look at what we need to be plugging into this particular problem. So we have my sample mean, 77.5. We have my sample standard deviation. I went and calculated this for you. So this would be given to you in the problem, or again, if you would be able to go and run it with summary stats with the data set itself, just like I did here. And then we have, so those all go over here to the left. Now, the other thing we need to pay attention that we have going on over here is setting up for our hypotheses. So again, we need to make sure that our null and our alternative hypotheses set up here in the dialog box match what we've already decided upon earlier in solving this problem. So here you can see that our null hypothesis, our HO, our mu, it's currently set at 0, but that's not the value that we have in our null hypothesis, so we would need to change that 0 to a 76. That would then change the value in the alternative to 76. It'll automatically make that adjustment. And so then you need to go through and select and make sure that your directional symbol matches with your alternative. So here we would need to change that to a greater than. So make sure that what you have here for your hypothesis test matches your null and your alternative that you've already set up. Now, as you can see here, just like with the proportions, you can also use the same system for doing a confidence interval, except for you would select the confidence interval for mu, right, instead of hypothesis testing. And again, make sure that you've got your correct confidence interval level there. So once you have all this information entered in correctly into your one sample t summary, you hit compute, and you should get an output that looks like this. Right, so here's our degrees of freedom, 39, our mean, 77.5, right? And we have our t-stat here is going to be 0.824942, right? And notice also it gives us our p-value as well. So when we put these in, keep in mind I'm rounding my t-value to 0.8, right? Because that is using our rounding rule as the decimal place that we have for our standard deviation, our mean. So we're going to keep it the exact same decimal place as those numbers because we're working with a summary. Keep in mind you put the full p-value in though. So you're going to want to have your full p-value here. Now, what's the next step I need to do? I need to do my p-value and compare it to my alpha. So let's go through, and if we're looking at this, we're going to have our p-value of 0.2072, set it up in comparison to our pre-selected alpha of 0.05, and ask if this is a true statement. If it is a true statement, then we would reject our null. If this is not a true statement, if 0.2072 is not less than or equal to 0.05, then we would fail to reject the null. So looking at this particular situation, would we reject the null or fail to reject the null? We would fail to reject the null. This is not a true statement. Okay, again, you would go through the same process using the flowchart that we've looked at before for writing your conclusion. Okay, so we don't go through that with this problem, again, just to time constraints, but you would go through and again add your conclusion using that flowchart. Now let's go back and look at this problem and solving it using the critical value method as well. So here we have our critical value method. We already have our test statistic. Now we need to find our critical values. So the first thing we need to do is we have an alpha of 0.05. We know that. We need to ask if this is a one-tail or a two-tail test. Again, looking at the different diagrams that we have here on the left, we can see that the symbol in our alternative hypothesis is a greater than symbol. That means that we are solving a one-tail. Okay? So here we're going to locate, so we're going to use our alpha as 0.05. Then we need to go in the t-distribution table and go through and locate. Notice we use the degrees of freedom of 39 and not our n. But we're using our degrees of freedom of 39. We're going to look for a one-tail test and for alpha 0.05. So to go through and look at that and locate what is going to be our t critical value for this problem. When you've got that selected, turn the video back on and let's check it together. Okay, you should have gotten a critical value of t equals 1.685. So that is our t critical value here. And we go back, and so we plug that in. And notice I've labeled that as critical value. You're going to see in a minute why I'm doing that, just for clarification. Again, because you'd have two t's, so it can become very confusing which t you're talking about. So I have my t critical value labeled with a lower CV. Now what's going to be my next step here? Next step is going to be to graph it out. So if we graph this out, here we can see a rough distribution diagram where we've drawn it in for this is a right tail, since that's what we're solving for, right? And we've got a rejection region marked off to the right of our t critical value. Notice that number there's just a little bit incorrect. Sorry, copy mistake, but it's 1.685 would be the t critical value, and the area to the left is where we fail to reject the null. So now we're going to take my t value and graph it in. Where is my t test statistic going to go in this? So 0.8 is going to map on here. Okay. Now notice when we're looking at this, I have added some additional symbology in. Again, it can be confusing if you've got two different t's. It's also confusing if you're solving a one-tail and you're using z's, because you're going to have two different z's. So I like to put a t with a lowercase t to designate that that's my test statistic. Right, and then I like to have my t critical value. That tells me that that is the critical value level that I've got to make if I'm going to reject my null. So think about adding those additional symbols into your problem solving to help keep yourself clear as to what each number relates to. So since we're looking at and we're assessing the rejection, so are we going to reject the null or are we going to fail to reject the null? And here we can see we're going to fail to reject the null. Our t-test statistic is falling within the fail to reject no region. And so again, you would go through and finish this up with using the wording your conclusion flowchart to write your answer for the final interpretation of this particular problem.